Hi guys, Mr. Johnny here, and this video is really a response, sort of, to a comment on my previous video. Previous video being the flashlight with AVR 80Tiny13. There was a comment from ZX841ZTV who mentions that he's not really a fan of microcontrollers, and neither am I, honestly. Back as a few days ago, I just was in a mood for it, and I made a software which really worked, as you saw in a previous video maybe. But I don't make much microcontroller project myself. I don't count blinking LEDs as a project, but that flashlight is a real project which found use and works very well. And I forgot to mention in previous video that controller also has a battery protection. It senses battery voltage, and if it drops to 3.2 volts, the only brightness you will have is just a low brightness. It will be on off on a low brightness. If it drops to 3 volts on a button, it will just turn off to protect the lithium ion batteries that's powering the thing. Okay, but he also mentioned the X841 that he would rather use an CD4017, which is decade counter, and have 10 brightness levels. Well, I thought like, that's actually interesting. And I recreated the same kind of flashlight using CD4017 instead of microcontroller. And here it is. I just made it on a breadboard to show you, because I don't really need another flashlight controller, so I'm lazy to lay out PCB for this mess and and build another. There is no need for that. Now, this thing, unlike the previous one, does not have any battery protection, and it's not a PWM at all. It's just a linear. This section, which you can see, is just a current source using that opamp, which is LM311. And you might say, oh, Johnny, that's a comparator. Yeah, it kinda should be a comparator really, but I got this off of eBay, and yeah, maybe. I hope you can see it. You kinda can see it. It's hard. Oh yeah. See? Which is really an op-amp. So I'm using the CD4017 instead of a microcontroller. Let me hook up the battery and meter, and I'll show you how well it works. It has 3 brightness levels, which you can see on these LEDs. This being the lowest brightness, medium and high. Okay, let me hook it up. Okay, I hooked it up, and on the 2 milliamp setting you see absolutely nothing. You actually can see just like 0.1 of a microamp flowing there, sort of, but it's not really, because I used that circuit again. And yes, this circuit is surprisingly, similar to the microcontroller based one. It just doesn't use microcontroller. Its place was taken by CD4017, and if I click it, you'll see the LED go on, and sometimes it jumps to the medium brightness rather than a low brightness, because when I hold the button too long, it will jump to the next brightness, but that's not really a show killer. See, as I mentioned, medium brightness, and we have, let me actually switch it to the lowest brightness. This LED is again like a power indicator. If it's off, the thing is off, 0 current. Okay. Lowest brightness, 16 milliamps. What's the LED? Okay. You can see the LED. And you can see a nice chase in action. That if I make a nice short pulse. If I don't make nice short pulse, it will misbehave. Okay, the schematic. Okay, the schematic looks like this. The transistor are used all FETs 27000s, PNPs 23906s, and PNs. These two guys are 23904s. And yes, this FET is also 27000 because I'm just using a little 5mm LED for the just to show it for you. I don't plan to use it in again, so yeah, this is just a prototype. Here you can see the same circuit that I took from transistor tester, and as a control signal for this, I call the signal on signal. I take the outputs of this Q0, Q1 and Q2, and I just limit the current here, so I really can get away using one resistor here, but you know, it's just a prototype. You can put one resistor here and just use 3 diodes. Why 3 diodes? Because it's an OR gate, it's a diode logic. So I OR these 3 signals, feed it here, so the thing latches. Then when you press a button, you effectively pulls first time. You turn this transistor on, turn the chip on, and the chip sets Q0 to high, and this current flows like that. Turn this transistor on, it latches. There is a LED voltage drop here. The moment you press a button, this transistor turns on. Turns on this transistor, which provides a rising edge on here on the clock input, which makes the IC provides one clock pulse. It triggers on a rising edge, if memory serves me right, and the logic 1 flips to the Q1, and you press it again, it flips to the Q2, and you press it again, it flips to the Q3, but Q3 is not connected here in any way, so Q2 becomes 0 when it flips to Q3, and therefore the power for this the power is switched off because this transistor is not on anymore. Yeah, and the signals here for a current source, I just use a linear current source. You can see just some voltage reference here and a divider to set a proper voltage drop, because again I don't want to drop too much voltage here. First fit, that will drop that will dissipate too much power on a resistor, and that will not allow me to draw that current when the battery voltage falls down to some threshold. And here these transistors are really just you know, like a switchable divider. Whenever Q0 is the lowest brightness, okay, and that's the default state. The moment you power on the chip, Q0 should be 1, and if it's 1, this MOSFET is on, and the divider looks like 10K and 100 ohms, lowest brightness. If Q1 is on, Q1 is high, the divider looks like 10K and 500 ohms, because those two 1Ks in parallel. And if the Q2 is high, it's not connected anywhere, as you can see, except to the latching power stuff. So the divider looks like 10K and 1K, providing highest voltage here and providing highest voltage here, thus highest current setting through the LED. And you don't have to use a linear current source. You can sort of make this very crude PWM, which I botched together, and I don't really know how well it's gonna work, but effectively what you have here is you have a linear current source with two PWM on and off, just like I did in the microcontroller based version. Here you can see the PWM, the circuit which actually creates PWM. This is just an oscillator. This comparator compares the sawtooth which it picks off of here to the voltage which is here, and this voltage is again from the reference with some divider which you have to pick for yourself, and again you have this two resistors and two MOSFETs providing a switchable divider, so you can choose the brightness. Choose the voltage here, and the voltage here will determine duty cycle and thus determine effective brightness here. Oof, yeah, 10 minutes, so yeah. I guess ZX8401 will like this approach, so yes, thanks for watching, see ya.